Welcome back. The topic of this interactive video lesson is an introduction to proportional situations. What is a ratio? Annie is an artist who illustrates children's stories. She uses some simple ratios when she draws her characters. When she draws young children, she uses a head-to-body ratio of 1:1. When she draws older children, she uses a head-to-body ratio of 1:2. And when she draws adults, she uses a head-to-body ratio of 1:3. Writing a ratio as a fraction. We often represent a ratio as a fraction. In this case, we can use head to body. For a young child, it's 1:1. The characters who are young children are drawn with a head-to-body ratio of 1 unit to 1 unit. The characters who are older children are drawn with a head-to-body ratio of 1 unit to 2 units. The characters who are adults are drawn with a head-to-body ratio of 1 unit to 3 units. A ratio represents a relationship between two things. What is a proportion? If Annie wants to draw an older child with a head that is 2 5/10 centimeters tall, how tall should the body be? We use the head-to-body ratio, then we set up a proportion. So 1:2 is the ratio, and we know that equals 2 5/10 centimeters to x. A proportion is a number sentence which states that two ratios, or fractions, are equal. What is the difference between a ratio and a proportion? A ratio is a relationship between two quantities, while a proportion refers to two equivalent ratios. 1 is in the same ratio to 2 as 2 5/10 is to x. Can you see a relationship between 1 and 2 within the first ratio? Sure, if we multiply by 2. To get from 1 to 2, we multiply by 2. So, to get from 2 5/10 centimeters to x, we also multiply by 2. Multiplying, we get 5 centimeters. So the body should be 5 centimeters. Let's practice solving a proportion. Let's add one more dimension to the ratio. The overall height is 3 units. Let's practice. Annie wants to enlarge her character to a poster size. The character will be 900 centimeters tall. What will the height of the head and body be? Pause the lesson and calculate the solution. Resume the lesson to check your work. Are you ready? Let's check. We know the total is 900 centimeters. We know the head-to-height ratio is 1:3. We want to know the head height for a character 900 centimeters tall. So the proportion would be 1:3 equals x to 900 centimeters. To get from 3 to 1, we divide by 3. So, we divide by 3 to get from 900 centimeters to x. When we divide, we get 300 centimeters. So the head should be 300 centimeters. So the head should be drawn 300 centimeters tall. Now for the body. We know that the head-to-body ratio is 1:2. We want to know the body height for a head 300 centimeters tall. So our proportion would look like this. 1:2 equals 300 centimeters to x. To get from 1 to 2, we multiply by 2. So we multiply by 2 to get from 300 to x. Multiplying, we get 600 centimeters. So the body is 600 centimeters tall. Three ways to solve proportions. First, look for a relationship within the fractions. For instance, 1 to 2 equals x to 36. Look at each fraction. Can you see a relationship within one of the fractions? To get from 2 to 1, we divide by 2. So to get from 36 to x, we divide by 2. Dividing, we see that x should be 18. Second, we can look for a relationship between the fractions. For instance, 3 to 2 equals x to 22. Well, look at both fractions. Can you see a relationship between the numerators or denominators? To get from 2 to 22, we multiply by 11. So to get from 3 to x, we also multiply by 11. And 3 times 11 is 33, so x equals 33. Always multiply or divide. Never add or subtract. Third, we can isolate the variable and solve. For instance, if we add 4 to 5 equals x to 26, then methods 1 or 2 are too difficult. So let's isolate x on one side of the equation. To isolate x, we need to undo the operation of division by 26, so we multiply by 26. The 26's on the right side divide to 1. On the left side, 26 times 4 equals 104. To find x, we divide 104 by 5, and we get 20 and 8/10. Let's practice solving proportions. Pause the lesson and solve each proportion. Resume the lesson to check your work. Are you ready? Let's check. We can look for a relationship within the fractions. So let's look at each fraction. Can you see a relationship within one of the fractions? To get from 3 to 1, we divide by 3. So to get from 75 to x, let's divide by 3. 75 divided by 3 is 25. So x equals 25. We can also look for a relationship between the fractions. Let's take the middle one. Let's look at both fractions. Can you see a relationship between the numerators or denominators? Well, to get from 5 to 20, we multiply by 4. So, to get from 3 to x, we also multiply by 4. 3 times 4 is 12. So x equals 12. We can also isolate the variable and solve. To isolate x, let's undo division by 28 by multiplying both sides by 28. Remember, what you do on one side, you have to do on the other side of the equal sign. The 28's on the right side divide to 1. On the left side, 28 times 3 is 84. To find x, divide 84 by 8. And we get 10 and 5/10. And that's what x is. Story problems with proportional reasoning. Sabrina buys 15 liters of gas for $20. If this is a proportional situation, how much would Kate pay for 60 liters of gas? Well, let's start here. Sabrina buys 15 liters of gas for $20. We want to know how much Kate pays for 60 liters of gas. So 15 liters is to $20 as 60 liters is to x. Setting up the proportion, it would look like this. Notice liters is on the numerator of both, and dollars is on the denominator. Let's look for a relationship within the fractions. Can we see a relationship here? Well, there's no obvious relationship. So let's look for a relationship between the fractions. Is there a relationship here? Well, we multiply 15 liters by 4 to get to 60 liters. So we multiply $20 by 4 to get to x. $20 times 4 is $80. So Kate would pay $80 for 60 liters of gas. In grade 6, the ratio of boys to girls is 4 to 5. If there are 45 girls, how many boys are there? Well, we know the ratio of boys to girls is 4 to 5. We want to know how many boys there are if there are 45 girls. 4 boys is to 5 girls as X boys is to 45 girls. So this is how we set up the proportion. Look for a relationship within the fractions. To get from 5 to 45, we multiply by 9. So, to find X, let's multiply 4 by 9. And that's 36. So there are 36 boys. Let's do 2 more. On a map of Nova Scotia, 2 centimeters equals 15 kilometers. If 2 cities are 8 centimeters apart on the map, how many kilometers apart are they? And, in a recipe, 3 servings of spaghetti requires 5 tomatoes. How many tomatoes are needed for 9 servings? Pause the lesson and solve the problems, then resume the lesson to check your work. Are you ready? Let's check. As we read through this, we see 2 centimeters is to 15 kilometers as 8 centimeters is to X. So our proportions would look like this. Now look for a relationship within the fractions. This isn't obvious, so let's look for an easier relationship. Look for a relationship between the fractions. How about here? We multiply 2 centimeters by 4 to get to 8 centimeters. So we multiply 15 kilometers by 4 to get to X. So 15 times 4 is 60. So X is 60 kilometers. So the 2 cities are 60 kilometers apart. Now in the next one, we see 3 servings is to 5 tomatoes, as 9 servings is to X tomatoes. And here's how the proportion would look. Look for a relationship within the fractions. Well, let's look for an easier relationship. We multiply 3 servings by 3 to get to 9 servings. So, we multiply 5 tomatoes by 3 to get to X tomatoes. 5 times 3 is 15. So there will be 15 tomatoes in 9 servings. How to identify proportional relationships? Is the side length of a square proportional to its perimeter? Well, let's look. We'll label the side length as X. And the perimeter will be Y. That's the sum of the side lengths. So Y is X plus X plus X plus X. Let's show this relationship in a table of values. If a square has a side length of 1, then the perimeter is 4 times 1, or 4. If a square has a side length of 2, then the perimeter is 4 times 2, or 8. If a square has a side length of 3, then the perimeter is 4 times 3, or 12. Let's add a column to this table for the ratio of Y to X. So first we'd have 4 to 1. Well, that's 4. Next we'd have 8 to 2. Well, that's also 4. Next we'd have 12 to 3. Again, that's 4. We can say that the side length of a square is proportional to its perimeter, because the ratio of perimeter, Y, to side length, X, is always the same, in this case 4. A proportional relationship can be shown as a ratio or an equation. This is Y to X equals 4, or Y equals 4X. Is the side length of a square proportional to its area? Well, let's see. We'll label the side length as X, and the area will be Y. So we know the area will be X times X. And let's show a relationship in a table of values. We'll let the side length be X and the area be Y. If a square has a side length of 1, then the area is 1 times 1, or 1. If a square has a side length of 2, then the area is 4. If a square has a side length of 3, then the area is 9. Let's add a column to the table for the ratio of y to x. So first we have 1 to 1, that's 1. Next we have 4 to 2, which is 2. And then we have 9 to 3, which is 3. We can say that the side length of a square is not proportional to its area, because the ratio of area, y, to side length, x, is not the same for different values of x and y. A non-proportional relationship cannot be shown as a ratio, but it might be represented as an equation. So the ratio of y to x is not constant. However, y does equal x squared in this case. Let's practice. Which of these tables of values represents a proportional relationship? Pause the lesson and solve the problem. Resume the lesson to check your work. Are you ready? Let's check. We'll check the ratio of y to x in each table. We'll add a column. First we have 3 to 1, that's 3. Then 5 to 2. Well, that's 2 and 5/10. Next we have 9 to 4. Well, that's 2 and 25/100. Notice since the ratios don't equal the same constant, it's not proportional. Now for the next one, let's add a column and look at the ratios of y to x. First we have 3 to 1, that's 3. Then we have 6 to 2, that's also 3. Then we have 12 to 4, well, that's also 3. So the ratio is constant, 3. So y to x equals 3, and this is proportional. Now let's look at the last one. In our last column we have 1 to 1, that's 1. 4 to 2, that's 2. 16 to 4, well, that's 4. Notice the ratios don't equal a constant, so this is not proportional. Using a table to solve proportions. You can use a table to help solve proportion problems. For example, if you have a problem that gives you a proportion in a form like 50 words per minute, 57 cents per centigram, or 1 6/10 kilometers per 6 minutes, you can use a table to extend the proportions. You can draw the table horizontally or vertically. We'll draw ours horizontally. Let's start with 50 words per minute. Janice can type 50 words in 1 minute. So in the first minute, she types 50 words. At this rate, she can type 100 words in 2 minutes. Or 150 words in 3 minutes. Or 200 words in 4 minutes. Or 250 words in 5 minutes, and so on. Let's look at 57 cents per centigram. Scrap copper is worth 57 cents per centigram. How much is 2, 3, 4, or 5 centigrams worth? Well, notice in the top, we add 57 cents each time, and in the bottom, we add 1 each time. So for 2 centigrams, it's $1.14. For 3 centigrams, it's $1.71. For 4 centigrams, it's $2.28. And for 5 centigrams, it's $2.85. Now let's look at 1 6/10 kilometers per 6 minutes. Jason runs at a steady pace of 1 6/10 kilometers every 6 minutes. So in 6 minutes, he runs 1 6/10 kilometers. Extend the table in intervals of 6 minutes. So in 12 minutes, he's run 3 2/10 kilometers. In 18 minutes, he's run 4 8/10 kilometers. In 24 minutes, he's run 6 4/10 kilometers. And in 30 minutes, he's run 8 kilometers. Let's practice. Complete the table for each situation. Pause the lesson and solve each problem. Resume the lesson to check your work. Are you ready? Let's check. Let's look at 1. A biker is riding at a speed of 2 kilometers every 6 minutes. So continue the pattern by adding 6 minutes for every 2 kilometers. So we would get 12 minutes is 4 kilometers, 18 minutes is 6 kilometers, and 24 minutes is 8 kilometers. Now for 2. Eggs sell for a price of 12 eggs for Canadian $3.60. Work backwards. Since 6 is half of 12, find half of $3.60. Well, that's $1.80. Since 3 is half of 6, find half of $1.80. Well, that's 90 cents. Since 1 is 1/3 of 3, divide 90 cents by 3. And that's 30 cents. All right, now we're ready to do more challenging examples.